this section, we're going to deal with essentially the reduction formula concept. And in here, I want to go through just, as I say, try and get a recipe. Here you can use a recipe. There is one that works very well for reduction formulae. We just have to deal with a couple of little bits and pieces first. Now, essentially, you know that the Cartesian plane is going to be divided up into, let's just check that we've got the, yep, we're on the right one. You know, we divide the Cartesian plane up like that, correct? ASTC, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right. Now you know that ASTC, okay, stands for all positive, sine positive, tan positive, and cos positive. We're going to essentially be looking at angles now that come into these quadrants over here. All right. Now this is theta, right? Theta is always acute. Okay. So what happens if we now say, let's say 120 degrees? 120, and you know on this side is going to be 60 degrees, angles on a straight line 180. Therefore, we now want to change that the 120 into an acute angle. We want to reduce the complexity. We want to reduce it from 120 to just an acute angle. Okay? So we're going to apply the reduction formula. They are very, very straightforward. Now, before we get to that, just let's think about something. What is minus 40 degrees or minus 60 degrees? How do we draw it? Okay. What do? We say, if this is our x-axis and this is our y and that's the origin, the negative angle is measured that way, isn't it? So this is minus 45 degrees. So therefore, if we've got a minus angle, right, we can draw it. We know that minus theta must be in quadrant 4. Why must it be in quadrant 4? Because it's acute, and you're only going to get acute angle either there or as a negative angle, aren't you? In other words, it's less than 90 degrees, between 0 and 90 degrees. So only there, if I have a negative, will I get that angle to be acute. So that is my minus theta that way. Therefore, any angle I can draw this angle here. Minus, I don't know, 180 minus 250 degrees. Okay? Can't I? Minus 250. So we can draw any negative angle if we go around. The next thing to just have a look at is, please bear in mind that in any of these here, there's my 360 degrees, right? Now, if I go around again, I have done 720 degrees. We can go numerous revolutions, okay? Then you must be saying, okay, but why? Well, it's basically just to let you sort of get used to the concept of the fact is that it repeats itself, okay? It's got a period and it repeats and keeps repeating. So there's many, many answers to the same problem, all right, as we have seen before. So now let's look at some, just some basics with regard to our angles over here, okay? In these quadrants, I'm going to put in, this is our quadrant of theta. This quadrant is 180 minus theta. This quadrant is 180 plus theta. This one is 360 minus theta. And no, you don't use 90 plus or 90 minus or 270 plus or 270 minus. Those we just leave for the moment. The quadrants are either a 180 minus theta, a 180 plus, or a 360 minus the angle, right? So any angle, let's just have a look at it then and say, all right, let us say, what about they say to us the sine of 120 degrees? The step one is to draw it. Just look where it is, okay? Because that you can do very quickly. Then it tells you that that is in quadrant number 2, which tells you that the quadrant it's in is in a 180 minus theta quadrant. Okay? So I'm going to say that the sine of 120 is the same as the sine of 180 minus something. Minus what? The sad part is most people put the 120 there, but it's not. It's 60, isn't it? How do I get that? Well, basically, you say 180 minus theta must be equal to 100. Because I'm solving for this angle, I'm changing my theta to be acute. Okay? That's all we're doing with these. So we're going to do a few, okay? So don't worry about it too much. But in essence, we're looking at saying any angle we're going to rewrite in terms of 180 minus theta, which means it's in quadrant 2, 180 plus theta in quadrant 3, or 360 minus theta means it's in quadrant 4. If it's in quadrant 1, in other words, if it's just theta, you leave it alone, okay? It's going to cancel out somewhere in these problems that we are going to do. So now in this situation here, we say, okay, there's something like 15 different ways that this can be asked. All right? I counted them in some reference book somewhere. They said, now, consider the most unusually or usually occurring ones. What I've done is I've looked at these over here. They say to you, simplify theta minus 360 degrees, okay? Or theta minus 180 degrees. Or minus 180 minus theta, okay? Or just minus theta on its own. Or a variation of that. We're going to get to the 90 plus thetas and the 90 minus thetas. Those are called cofunctions. Let's get there later. So they say to you, all right, what is the sine of theta minus 360? How? Now, you can go through by all means. If you've got a great memory and you take a snapshot with your brain, that's wonderful. But for the rest of us poor mortals, we don't work that way. I've got a firm belief I don't like memorizing stuff. I like to be able to work it out. So what do? I say to myself, let me find a way to work these out that I can quickly, without being confused and have to remember a table, let me see how I can do it, all right? Let us start with theta minus 360. They say to us, simplify theta minus 360 degrees. Then I say step 1 is find the angle. And its quadrant. Find the angle and its quadrant. What do I mean by that? I mean draw it. Absolutely. Drawing these things is the only way to go. And let's have a look. Okay, theta minus 360. Okay, so I first draw theta there. Why did I do it there? Because theta is an acute angle, always by definition. So wherever I see theta, I know it's that. Now the next thing is they say, now I'm going to subtract 360 degrees. Where do I go? I go back to theta. So theta minus 360 degrees is in fact theta. It's in quadrant 1. Therefore, okay, just go back to, therefore, all trig relationships are positive because it's an ASTC. So step 1 is I find where the angle is and then I apply this funny bits and pieces to it. Okay. So let's have a look at the next one. All right. We say, okay, where it is, it's in all formula will work and no reduction formula is needed. So we don't need a reduction formula. All right. That's quite straightforward. Okay. Pretty simple. And there we go. Now, what about the next one is theta minus 180 degrees? They say, for example, they say, what is cos of theta minus 180 degrees? Okay. Yep, you've guessed it. Step 1, draw the angle and find out where it is. Theta first. There it is. There's my theta. It's acute. The next step is apply what they tell me. Subtract 180 degrees. So where does my line go? my line is actually over there, isn't it? So it's in quadrant 1, 2, 3, A, S, T, C. 4. It's just so this function is in quadrant 3, which means what? Which means this is going to be cos of theta minus is minus cos theta, because it's there. And I know that theta is going to be negative in that thing, right? Okay. So therefore I will use, okay, that's what it's going to be. But now how do I get to that? I say, right. And this is the step to go through, right? You say, right, first of all, there's my angle, right? That's step 1, is find that. Okay, let me put these in green, shall I? Step 1 is find the angle. Step 2 is apply whatever they tell you to do to it. Your angle is 99% of the time going to be in the first quadrant. Then subtract or add 180 degrees. Step 3, okay, is find the quadrant. Step 4, rewrite as 180 minus theta, 180 plus theta, or 360 minus theta, depending upon which quadrant it is in, right? Depending upon which quadrant it is in. So when you found the quadrant, you say, aha, you are 180 plus theta quadrant, therefore cos of theta minus 180 degrees, and I'm going to go back to black, equals cos of 180 plus theta degrees. Okay, there we go. Now apply reduction formula. Okay, I'm going to put in my next step. 5, apply the correct reduction formula. Okay, so that's that step, isn't it? That is step number 5. Okay, can you see number 4 was rewrite as that. Number 5 is apply it. Therefore, I can say cos of 180 AST is minus cos of theta. Okay, now let's look at the next one. Can you see these are actually quite simple? They look pretty difficult in the beginning, especially if you're trying to remember 15 different bits and pieces with more to come. Okay, let's have a look here now. What about minus theta? All right, minus theta. All right, let's say they say tangent of minus theta. Well, step 1, draw theta. Theta is acute. Minus theta, there she is. Okay? Okay, this is quadrant 4. Quadrant 4 is 360 minus theta. Therefore, rewrite of, I was going to do cos again, rewrite tan of minus theta is equal to tan of 360 minus theta. That's my quadrant, which is equal to minus tan of theta. Why minus tan? Because there's my diagram. ASTC, tan is negative. Okay, in the fourth quadrant. So here's a one that's slightly more difficult. Okay, probably the most complicated of all. Lastly, let's have a look here. They say, let's say they say sine of minus 180 minus theta, or minus theta minus 180, doesn't matter. Step 1, find the angle. Let's find it. Okay, it's minus theta, so I am there, right? That's my acute angle. Now they tell me subtract 180 from it, okay? Which means go this way around 180 degrees. There's my minus 180 degrees, isn't it? So therefore, next is apply which quadrant? It's going to be equal to sine of 180 minus theta, which is going to be equal to sine theta. Okay. So you go through the steps instead of trying to, and you'll see when we're going to do some examples now, you see they get quite complicated and long, very prone to mistakes. Okay. But rather apply these little recipes. What they do is they take it from maybe 1 or 2 to full marks for that piece. Okay. Just by applying this, I kid you not. Okay. Well, like any recipe, I guess, hey. So as long as you apply it properly. So in any case, we can apply these recipes, can't we? We can see where we are in it. We're going to do it with co-functions as well. All right. Now, what we're asked to do in reduction formula, right, is they're going to give us a whole long expression, and they're going to say simplify, right? Now, you know, you've done this since time immemorial. Back in grade 7, right, you start simplifying. Why? To make it smaller. That's what this is about. So we're going to make it smaller. So things that look quite big and odd, we're going to make a lot smaller. Let's have a look at a recipe for these. Okay, this is for simplification. Simplifying using reduction formulae. Okay, simplify using, okay, number 1, always look where the actual angle is. Look where the actual angle is, i.e. sketch. Do a little cross and say, my angle is there. That's the quadrant I'm in, okay? I.e. which quadrant? Okay. Step 2. Okay, when you've got which quadrant, okay, in fact, I'm going to put that as decide which quadrant. Same thing, really, hey guys. I just decided to do it as a step. Step 3, apply the correct reduction formula. Formula depending on the quadrant. Okay. So there we go. Oh, need another page. Number 4. Okay. Apply ASTC to the reduction formula to get the correct sign, plus or minus. Okay, and number 5 I put in, and I'm going to put it in red. Yep, again, like I've always done, use brackets. Because if you don't, I'll give you 3 guesses what's going to happen when you see these. It's going to go completely pear-shaped, right? Use the brackets. They are your safety belts. They won't let you down ever, okay? So let's, before we kick off, all right, let's just quickly have a look. Let's just convert a few. All right, what is, let's just do an example. Okay, of 135 degrees. Okay, so theta is equal to that. Find it. So we say, right, first of all, I do a little drawing. I say, you are up there. There's my 135 degrees, right? You'll see how valuable this is with negative angles in a bit, hey? You really will. 135 degrees. I say, okay, I'm in quadrant 2. Quadrant 2 is the 180 plus the 180 minus theta. Okay, That's the quadrant. I know it's my 180 minus theta. It's always the same quadrant, okay? The same formula apply to those quadrant always, okay? And it's a 180 minus. Therefore, 180 minus theta must be equal to 135, because remember the angle I'm looking for is that. So therefore, theta is going to be, and it's going to be equal to, and please remember, minus theta is going to be 135 minus 180 is minus 45. Therefore, theta is equal to 45 degrees. So therefore, I can do anything now, and 135 I change to sine or cos or tan 180 minus 45. Okay, that will give me my angle. Let's try a different one. Example, what about 235 degrees, shall we? Okay, so theta equals 235 degrees. What do? I first of all make a little rough sketch. I am here, somewhere there. The angle I'm looking for is that one, isn't it? That's going to be my new acute theta. Okay, I know different textbooks call it different names, okay, but let's just cut to the basics. This is what we're trying to do here. So I say, all right, therefore now, sorry about that. Therefore, what happens next? Next, I say, okay, I'm in quadrant 1, 2, 3. So I pick the quadrant 3, apply the correct formula. It's the 180 plus theta quadrant. Find theta. 180 plus theta must be equal to 235 degrees. Theta's 235 minus 180. 235 minus 180 is equal to 55 degrees. Okay? Straightforward. Right? That's the little recipe that will get you right into the heart of these and crack them wide open like a nut. Okay? Without any problem at all. Okay? Right? Okay. Let's say, for example, though, they do an example like this then. Right? Let's say they ask us, find the tan of 225 degrees. So what do? I draw it. I'm in that quadrant, right? So I draw it. Step done. Quadrant. It's in quad number 3. What's the formula? 180 plus theta. Therefore, find theta. 180 plus theta equals 225. Theta equals 45. Therefore, it's going to be tan of 180 plus 45, and then apply ASTC. Tan is positive, so it's plus tan of 45 degrees. It sounds like a lot of work, doesn't it? But once you get the hang of it, you'll do it in your head, right? You'll do it mentally. You won't be going through the process as I am at the moment. All right. Now, essentially, in any of them, all right, we're going to be looking at, let's just do one more, sine of 300 degrees. Whoops, my bad, sorry. That was a really bad example, wasn't it? Well, written form of it. Example. Right. Let's say they ask us for the sine of 300 degrees. Okay. Step 1. I draw it. I see it's in quadrant 4. Therefore, it is in the 360 minus theta quadrant. Therefore, 360 minus theta must be equal to 300. Therefore, theta turns out to be 60 degrees. All right? All right. Right. Theta turns out to be 60 degrees. Then I rewrite it and I say that is then going to be the sine of 360 degrees minus 60 degrees. I can check that is 300 degrees, which is what I was asked to do, isn't it? All I've done is I've actually making that look neater. Random. 300 degrees, right? I'm tempted to write centigrade next to it, don't ask why. But 300 degrees there, and it's the correct thing. Then I apply ASTC, so I'm in the fourth quadrant, therefore sine is negative minus sine of 60 degrees. Done and dusted, okay? The last part of this, before we get into, there's co-functions as well to go. Please remember, okay, the special triangles and to draw them, all right? 30 degrees, 60 degrees, and 90 degrees. For those of you who do EGD, these are the two triangles here, aren't they? There they are. There's the 30 degrees, 60, and the 90. And here's the other guy that we have to draw, the 45 degree, right? Because this is both sides equal length over there, which means base angle is the same. It's isosceles, right? So therefore, we have to remember it. I'm afraid that's the only way out of this, is to memorize it. And for those of you who do drawing, it's easy. That we call 1 unit, and that's root 2 by Pythagoras. We call that 1, 2, and root 3. So therefore, now these are special angles. Okay? Special angles. Okay? Very important. Okay? Special angles, very important. And in each and every case, there they are, you can see that we're going to be many times, we're going to be reducing it to the special angle, right? And then we can work it out because they say without using one of these chaps over here, okay? Or one of these girls, whichever if yours is a girl or guy. What we do is we say, right, we reduce it to a special angle. Always be aware of these special angles. They come in repeatedly, okay? Especially when they say without the use of a calculator. They expect you to use the special angles, or it's going to come down to special angles, right? So an investment in time is very worthwhile to remember those and test yourself on it. How do I remember it? Well, I remember it and I say in my head, I can see the triangle and I say the short side must be 1. And I know it's a 2 and a root 3, so I have to decide which is which. 2 is bigger than root 3. Check it on your calculator. Root 3 is 1.732, I think, so it's bigger. The hypotenuse must always be the longest. So the shortest side is 1. Shortest is 1. Then I say 2 and root 3. Okay, what do I do next? Next I say, this one is 1 and 1. Shortest side must be 1. You've got 2 short sides, they're the same. That's a root 2 over there. Okay, I think there's probably mnemonics available for those, but what you have to do is you have to remember them. Okay, next we're going to look at co-functions. Okay, then we're going to do a pile of simplification examples in these. All right, and we're going to go through some pretty tough ones, but just chill because it actually works out quite easily. It seems very complex. Honestly, it does, but it's not. I'll be back in the next one. Remember what you're going to do in the meantime? Yeah, learn those triangles. Very worthwhile. Cheers. Bye.